In question 5.1, we're to show that the linear speed of the acrobats is about 4.5 meters per second. Well, from the diagram, firstly, we just verify that tan of 28.5 degrees is equal to the opposite over 5, the distance from the vertical distance from the platform to the acrobat. Therefore, the opposite, which is what we want to add to get our diameter, is equal to 5 tan 28.5. Then the radius is the 1 meter radius of the platform plus the extra distance that the acrobats are out by being on their rope, which we've found is 5 tan 28.5. Then v is equal to distance over time. Speed is distance over time. The distance is the circumference, which is 2 pi r, and the time is the time period t. Putting in the values, we have 2 pi, the radius we've found above a 1.0, plus 5 tan 28.5 over the time period, which we're given as 5.2 seconds, giving a speed of 4.49 meters per second, which is around 4.5 meters per second as required. In 5.2, we're to find the tension in each rope. Well, the tension times the cosine of 28.5 is supporting the weight, mg. So the tension is mg over cos 28.5. The mass, we're told, is 85 kilograms. G, as usual, 9.81 over cos 28.5 gives a tension of 948.8 newtons, or 950 newtons. In 5.3, we're to discuss the consequences for the forces acting on the pole when one acrobat has a much greater mass than the other. Well, the greater mass acrobat has a greater weight, therefore a higher tension in the rope. This will give a higher compressive force on the pole. They'll also require a greater centripetal force to be able to go round at the same speed. This causes an unbalanced force at the top of the pole, which will thus bend towards the greater mass acrobat.